Okay, we're going to go on to move back to text and text 4. We've got a bit to tidy up in text and text 5, but only a small bit. But text and text 4, I want to go back and quickly get through this chapter really. It's not as important as the other trigonometry chapter, but you'll notice that it doesn't really deal with looking at angles, but just the relationships between sine, cos and tan mainly. So a trigonometric identity is the relationship between the ratios, or the link between them. Okay, so we're used to seeing sine, cos and tan, but there's also these ones, cosec, sec, cot, cosec up here is another one. They've just listed it slightly differently. Okay, so these three in your maths tables, they're on page 13. Okay, up the top. So 13, 14 and 15 are the pages we're going to be using for the next for this chapter. This is also an important one. Tan is sine theta over cos theta. Okay, so they might use theta or they might use A. They use A in your maths tables, but in the questions they might use theta or they might use B. It doesn't matter. Okay, so these are actually all listed here. So there's the cosec, sec, tan, cot. Okay, so you can see they have cot as 1 over tan A, but actually that's the one in your maths tables because 1 over tan A is that. If you put tan A is sine A over sine theta over cos theta or whatever, 1 over it is just going to turn upside down. So what I want you to do is take down this yellow box because this covers these ones here. These are in your maths tables again, page 13. An important one is this one, that sine squared theta plus cos squared theta is 1. If you rearrange that, I also want to take down this, that sine squared theta is 1 minus cos squared theta, or if you have cos squared theta, that can be written as that, meaning that if you have sec theta, you can write it as this. If you have sine squared theta, you can write it as this. And again, it's just going to be manipulating things to prove things, really. Okay, also in this chapter, there's going to be mandatory proofs. So this is your first mandatory proof, nice and simple. That diagram we looked at before, in the unit circle, this is, sorry, I'm just going to focus in on that. In a unit circle, any point is cos on that circle is cos theta sine theta. So they just use the distance formula here to prove it really. Okay, so it's just 3 lines, a nice simple proof to start with. So the mandatory proofs I'm going to be getting you to take down, and we'll be talking through them. And when we see them in questions, you'll be able to practice them as well. Okay, so what I want you to take down first of all is trigonometric identities. This yellow box, followed by these two as well, and the first mandatory proof. And then I'm going to go through 3 examples. Okay, so just pause it there 1 sec. Right, these are the sort of questions you're going to see. So you're going to have your tables to hand, okay? And what you're generally not going to be dealing with these sort of questions with triangles and looking for angles. It's generally you're going to be asked to prove something, that the left-hand side is equal to the right-hand side, and you're going to use what you know from page 13, 14 and 15 to manipulate one of the sides to make it look like the right-hand side. Okay? So on this one it says, prove that sec A minus tan A sine A is equal to cos A. Now, what you do with this is you pick a side that you're going to manipulate. And obviously the side that looks easiest to manipulate, it's generally going to be the left-hand side because you've got loads of stuff. Is there anything that we could change sec to that in terms of cos? And there is. Look, sec A is 1 over cos A. So instead of sec A, I write 1 over cos A minus. Is there anything we can change tan to that will relate to cos? And there is, up here. Tan A is equal to sine A over cos A. Times sine A. because I haven't done anything with that. So we're just dealing with the left-hand side here. So all I've used is I've changed the sec to 1 over cos A and the tan to sine A over cos A. If I rewrite that, I get 1 over cos A is minus sine squared A over cos A. My knowledge of fractions, are the denominators the same? Yes, so you can write that as a single fraction. So that's 1 minus sine squared A over cos A. And again, we want to deal with cos here. So what is 1 minus sine squared A? Remember, if we rearrange this, going back to our maths tables, 1 over sine squared A, this is the one I got trying to manipulate your fraction to make it look like the right hand side. Okay, that's the first one. Second one, obviously we're going to be working with the left hand side here. It says prove this left hand side is equal to sine theta. So we want to somehow relate this tan theta to sine theta. So we go to our maths tables again. Tan theta can be changed to sine theta over cos theta. So it's sine theta over cos theta. And can I change this to something? Now, I want sine. So it's with practice you get this. 1 minus sine squared theta. Can I change that to something that's just one term? And there is. Remember, rearranging this, like I said before, if I bring the sine squared over here, it becomes 1 minus sine. This can be written as cos squared theta. And why this is important, you might be saying, why am I changing it to cos squared theta when I'm looking for sine? Because look, I notice that there's a cos down here. I need to get rid of this. Okay, next example on the next page is prove this left hand side equals the right hand side. Again, it's mostly the left hand side you'll always have to change. But if this was on the right hand side, I would try and change this. So you look at what tan is. Again, I'm keeping this to hand the whole time. Tan theta is sine theta over cos theta. So sine theta over cos theta. This is just the top I'm dealing with here. Plus sine theta. All over. Again, I'm going to change the sec because there's no sec here. So sec is 1 over cos theta. Just so you can see that there. They have A in the maths tables, but obviously it's theta in the question. So that can be 1 over cos theta plus 1. Now you can see, again, rules of fractions. Cos theta on the bottom, cos. So if I multiply this term by cos theta, this term by cos theta, just to get rid of the fractions within the fraction. So I'm going to multiply everything by cos theta. Everything by cos theta. So that's just, so this multiplied by cos theta would cancel out, so you're just left with sine theta. This multiplied by cos theta is sine theta cos theta. So these two. That's the top. The bottom, cos theta times 1 over cos theta is just going to be 1, and then plus cos theta, because 1 times cos theta is cos theta. How would you know to do that? From your rules of fractions. You want to sort of express these as a single fraction. You could have expressed them as a single fraction, divided, turn them upside down, multiply. Same thing. You get the same result. Now, here's where, again, where practice and knowledge, we want to be left with a sine theta. So we want to be left with this. So I go to my maths tables and saying, is there anything that I can replace sine theta cos theta with? Okay, is there anything that I can replace? And this is where your knowledge of fractions, I suppose factorizing as well. You're like, what's common to both of these? Sine theta. So I don't want two sine thetas, I want just one. So if I just factorize the top. Now, again, through practice, you'll start to recognize tricks like this. I've taken a sine theta out, so it becomes 1 plus just cos theta, and I'm left with 1 plus cos theta on the bottom. And what can I cancel out there? 1 plus cos theta, 1 plus cos theta. So we're just left with sine theta, and that is equal to the right hand side. That's what we're asked to prove. Okay, again, you'll get most of the marks for substituting in what you know from your maths tables, but then there's a bit of cleverness in terms of how we rearrange fractions and how we manipulate it even further to get what we're asked for. Okay, and one more example. Okay, this is a bit different because look, the right hand side doesn't have any. You're asked to prove the left hand side is equal to the right hand side. The right hand side doesn't have any sine, cos, or tan in it, and none of those, except for this one, obviously, don't have that. So there is some other ones you can use, and this is stated to you on page 306 in your books. You can substitute in the sine rule and the cos rule. So obviously it's the cos rule here. So if I go to my maths tables and look up the cos rule on page 16, here's my cos rule. Remember, I rearrange this to write the cos rule. If I rearrange it, cos A is equal to b squared plus c squared minus a squared all over 2b c. Remember we did that when we were doing the cos rule. If you were looking for the angle, you rearranged it. So instead of cos A, or cos B in this case, I'm going to substitute in this. Again, if it's cos B, these will be slightly rearranged, so bear with me. So I'm going to leave the C there. And the reason it wouldn't have said use the cos rule, but the reason I'm using this and would have known to use this in the exam, because look at the right hand side, it's just got the letters. So I would substitute in it. So cos B, instead of that, I'm going to put in the other two sides, a squared plus c squared minus the letter. So this is slightly different to this because it was a here, it's b here, divided by 2ac minus b times cos c. So cos c is equal to a squared plus b squared minus c squared all over 2ab. I know now that this c will cancel nicely with that c, that b will cancel nicely with that b, and now I'm just going to multiply at the brackets. And remember, this can be all put over 2a now, because my rules of fractions, the same denominator, this is all over 2a. So I have a squared plus c squared minus b squared minus a squared minus b squared minus c squared plus c squared. The a squareds will cancel. A squared minus a squared is 0. I have 2c squared minus 2b squared all over 2a, and we can divide everything by 2, and we end up with c squared minus b squared all over a, and that is equal to the right hand side. I should have mentioned, I was constantly looking up here just to make sure that I was getting towards the right answer, and you'll keep that in mind. So that's when I use the sine rule or the cos rule. Okay, I use the cos rule in that particular point. And actually in the example in the book, it writes out, if you want to write out exactly what cos B and cos C are, it writes it in the book as a previous line. Alright, so I'm going to give you a few questions to try. There definitely will be questions on this. It's something that people find difficult to start with, and they get more comfortable as they go on. So remember, it's the double today, so spend a bit of time on them, and if you have any questions, please ask. And you can see in the next section, 8.2, there's quite a lot of mandatory proofs, okay?